So, good morning, good afternoon, and good evening. Hope you are all doing well and staying safe. On behalf of BioPetro, I want to welcome you all to today's webinar about effective Python programming for exploration and production. Today's webinar will be presented by special guest speaker, Engineer Yohanes Nuwara. Engineer Yohanes is now working as a distributed acoustic sensing geophysicist in the RITE Institute in Japan. He holds a bachelor degree in geophysics. In addition, he had achieved outstanding achievements in many places. One of them was the minus CO2 challenge by Equinor and EAGE in 2018. He had several high-ranked publications. One of them is about integration of rock physics, time-lapse seismic modeling, and geomechanics for CO2 storage, which he will present in the 22nd EAGE Annual Conference this October in Amsterdam, Netherlands. He had been working also on open-source Python programming programs for geoscience and petroleum engineering since 2020 and has been teaching more than 1,000 SPE students and professionals worldwide. Besides, he writes blogs about data science, and he has been actively involved in his Python for geoengineers community on Telegram. So please join me in welcoming Engineer Yohanes. I'm sure all are excited to know more about Python programming for exploration and production. And on a final note, if you have any question related to the technical content of the presentation, please feel free to drop it down in the Q&A section. Now, without any further ado, Engineer Johannes, the mic is yours.
Thank you, Mariam, for your kind introduction. Hi, everyone. Welcome to the first session of this Python training, Effective Python Programming in Oil and Gas. If you want to ask some questions or you want to interact with me, you can just freely call me Yohanes or Nuwara or whatever you want to call me. And basically, today we would like to discuss a basic tutorial in how to start Python programming, which is specific in oil and gas industry. I believe that some of you may be you are right now joining online courses in Coursera or EDX or Udemy on learning Python. They are all good. But here I would like to stress some applications of Python programming in oil and gas. So how to effectively program something and how to creatively make something, because that's a quite important ability to do effective programming and create lots of creative stuffs from Python. So the format will be in training. I will give a hands-on tutorial using Google Colab. And this will be 4 sessions started from today. And in the upcoming 4 weeks, we will go about different topics in Python. So today, we would like to start Python. We would like to get to know Python, what is Python, and how to do coding in Python, and and knowing lots of libraries in Python. So basically, Python is a programming language. It's not a software. It is quite interesting because about 70% of people still know that Python is a software. Python is not a software because the difference between software and programming language, software is an application. You can use it. It's like you can interact with it. Like Petrel, it's a software, it's an application. But programming language is it's a programming language in how we can code something, and from this programming language we can do lots of things, including making a software. So Python is not a software; it's a programming language. And the good thing of Python is that Python is open source and it's free. So you don't have to buy Python because Python is free. Python is free of charge. You can run anywhere. And today I would like to introduce you to Google Colab. It's an IDE And basically, IDE it's a kind of application where you can run Python. There are lots of IDEs, for example, PyCharm, Anaconda, and maybe Spider and Visual Studio. And another useful IDE is called Google Colab. Google Colab is free, and it can be run online. So you can run anywhere. Even you can run in your smartphone or your any other device free. So it's quite interesting to use Google Colab for Python programming. And the good thing is that Google Colab has lots of memory, and it can run even faster than you are running Python in your computer. So today I would like to share you a hands-on tutorial on how to use Python in Google Colab. Basically, there are lots of libraries in Python. A library is a class. So in general, I discussed about what is Python and what is an IDE. And one of the examples of IDEs are Google Colab, where you can run Python online and it's free in the internet. Later today, I will share you a tutorial on how to run Python in Google Colab. There are lots of libraries in Python. One of the examples are NumPy. NumPy it's quite often used by people. Why? Because it does mathematical operations. If you are working with math, you are using NumPy. If people are using NumPy for accessing files and do some more advanced stuffs, for example, multidimensional data operations and statistical simulations. The second library, it's called the Matplotlib. It's a library for plotting. So if you want to plot something, you are using Matplotlib. It creates lots of graphs. For example, in the oil and gas industry, we know about volumetric mapping, how we map an OOIP or original oil in place. It uses a contour plot. And to use a contour plot or to make a contour plot, we are using Matplotlib. And there are lots of things that lots of plotting types we can use the Matplotlib. For example, also we can do the plotting of 3D trajectory of a wellbore and to produce the top formation, surface structure, and anything else. And also we know there is a library for data processing. We are discussing about Pandas. Pandas is a library for data processing. We are when we are using Microsoft Excel in Microsoft spreadsheet in Microsoft Excel, we are using Pandas in Python. Some of the advanced uses of Pandas is, for example, time series analysis, data wrangling, and data analytics. The next library is called Scipy. Scipy is a library for scientific computing. It does, for example, root finding and other numerical methods. We know in engineering, interpolation, extrapolation, and other things, for example, statistical analysis and lots of other things. So in oil and gas, all operations are used using numerical methods, and we are using lots of data. We are processing a huge amount of data. So Python is quite useful. But the most important thing is the way we have to do an effective programming. There is an ability to translate a problem into a code. And it's an ability to run a program or to create a program in a short lines of code. So you don't have to produce long lines of codes. If you can make, for example, only 10 lines of codes, you're just doing it effectively. So it's called effective programming. So now I would like to start the tutorial, and one thing that we have to do now is we connect to the internet, and because we are using Google Colab to run Python, so here we can just type colab.research.google.com, and you will access everything that you can do in Python. So the appearance is just like notebooks and any other IDE, for example, PyCharm, and it's free and you can run it online. So the next thing is you can create a new notebook here. And make and in this notebook or in this page, you can create your own program in Python. So here, this is the title, and we rename it, for example, session 1 introduction. Okay, and in this notebook, you can do anything you want. Okay, but before you do Python, you have to connect it with the internet. Okay, and then you import all of these libraries, because when we want to do something in Python, we have to import several libraries that I have mentioned before, for example, the NumPy, Pandas, and Matplotlib. And the way we are importing the library is just by typing like import numpy as np. This is our first library that is called NumPy. If you are still remembering it, it's a library for numerical computation. We quite often use NumPy in everything we do in Python. And the next library is called Matplotlib, okay? pyplot as plt. Maybe some of you are wondering why we write like this, import numpy as np. Well, you can, we can change this into other names. For example, import numpy as your name, and as my name, for example, it's as Nuwara, okay? And it's fine because it's just a naming convention. You can naming it with anything you want, but because we are quite often use NumPy, we use importing NumPy as NP. It's an abbreviation of NumPy. And matplotlib.pyplot as plt, this one is for plotting, okay? And import pandas as pd as our third library. And in this tutorial, I would like to show you also to use Scipy, okay? And okay, so just all of these 4 libraries are enough for today. So we are done with importing libraries. And after this, we can do anything we want in this notebook. The first thing maybe is how to make an array, because array is the most basic thing in programming. For example, I can make an array. I name it as X, and the way we are doing this is using np.array, okay, numpy.array 1, 2, 3, 4, 5, 6, for example. Why I have to write this one, np.array? So np is the library, it's numpy, and from this library we are accessing a function that is called array. So this function array is located inside this numpy library. So this is the way we are doing in Python. We specify first the module, and then we specify the library, the function that we are going to use. For example, here we would like to create an array, and we print it. It would display our array. Another way of making an array is without numpy.array. We can do like this. In Python, it's called a list, okay? So this one will print the same. So this one is making a list using numpy array method, and another method is using list, making a list using list. Okay, list. So there are two ways we are using numpy array method and list method. Why we have to differentiate these two methods? Because it's quite important to know that when, for example, I would like to copy this. Okay, this is the first method, and then I change into another method. I use list 56. Okay, and it's a quite important to know this, because sometimes people prefer list over numpy, or prefer numpy over list. So it's up to you. You want to use list or numpy, because it's your preference. And then we have to know how to make an array. For example, we would like to produce an array from 1 to 100, divided into 50 numbers. Sorry, 50 numbers. We are using this numpy.linspace. Okay, specify the first variable, sorry, the first number, and the last number you want is 100, right? Sorry, this is 1. Start from 1 to 100 into 50 numbers. And if we print the array, okay, we will see the result. Also, we can also produce an array, but for example, we would like to produce an array from 1. We would like to specify the increment. So it's the increment. For example, the increment is 2. Okay. So instead of using linspace, we are from 1 to 100. We print the array. Okay. So if you look at this, the increment is 2. Okay. So we would like to make an array that using an increment, we are using a range. If we want to make an array divided into certain numbers, we are using linspace. The next thing is, from this array, I would like to plot something. Okay, so maybe we will continue into another concept in programming that is called making a function. For example, we would like to make a sine function in Python. We write as this one, def, maybe, for example, the name of our function is sine function, and the input is x. Okay. And here we type the formula numpy.sin, okay, x, and we return the y variable as our output. Okay, we run this cell, and if we want to use this function, we can make a new input. For example, we name it as c equals an array from 0 to 360 divided into 100 numbers. So here, because we are using this method, we use linspace. Okay, so this is the array from 0 to 360 degrees. But be careful, because Python working with trigonometric function in Python, it requires that your input is in radian. So because this is still in degree, we have to convert it into, we have to convert it into radian. So we can use numpy.degree to radian and see, okay? So if we print the result, we will get all of the angles in radian. And on this input, we will we will convert this input into a sine function. So we declare the function first, y equals sine, and the input is c. And if we print the y or the output, okay, it will print all of the results of the sine function. Okay. So this is the basic of NumPy libraries. The next thing is how to plot these results. Remember that before we know Matplotlib is a library for plotting. So to plot something, we are using Matplotlib. And here we have already import our libraries, okay, that is called as to use a function declaring the library first, that is PLT, okay? And the name of the function that we use for plotting is plot. We use the plt.plot, and this one is our x-axis, C, and the y-axis as y, okay? And the second line, we put plt.show to show our plot, okay? So this is our sine function. Another thing, maybe would like to add some attributes to make it more beautiful, or we would like to resize our plots. We can use plt.figure, okay, and specify our figure size, for example, of 7 and 5, okay. Resize it, and we would like to, maybe I would like to add some grids here, okay. And the fun thing about Python is you can change a style of the of Matplotlib. You can so I would like to show you this plt.style. I would like to change my style into another styles. For example, I would like to use classic, okay, and you will see the difference. It's there are lots of styles in Matplotlib, and you can explore it yourself. And if you want to search other styles of Matplotlib, you can just browse it. All information about Python and all functions are in the browser. You can read the documentation, or you can read in the Stack Overflow. There are lots of examples that people are going to explore more and more in Python. Maybe another style is called Seabourn. So you can see all different styles of plotting. For example, this one is also one of my favorite style in Matplotlib. Maybe for this, I would like to leave it as classic style. Okay. And then for this plot, I would like to give the labels. This is the X in degree, and the Y label is Y, okay, because it's the amplitude of the sine function, and the title is sine function, okay, the sine function, and we can resize our title. We use size 20 and pat 10. This one controls how far the title is from the plot. So I would like to make it farther away from the plot. Okay, you can see the difference, right? and smaller size. Okay, and also we can specify the labels. For example, here's size 10 and size 10. Okay, so that's all. This is the basic of plotting. Or also we would like to specify the color as purple and add a legend here. We give the legend the sign or y equals sine x. Okay, and don't forget, if you want to add legend, sorry, this is not legend but label. If you want to add the label, you have to add this plt.legend to make it to turn on the labels. If you don't turn on this plt.legend, for example, you forget to write plt.legend, it won't show anything. Okay, so it's quite important to write this plt.legend to show your plot. And I would like to restrain the x-axis from 0 to 6. Okay, so x limit from 0 to 6. Okay, it will restrain our function. So that's the basic thing we are doing in plotting. We want maybe two plots side by side. We can do another. We can make another trigonometric function, cosine, for example, x, and this is our second function, y equals np dot cos x, and return x. Okay. So I'd like to make another array for this is for our sine function, and another is for the cosine function. So so C is still similar, and here y1 is for our cosine function. Okay. So if I would like to plot all of these trigonometric functions into just one plot, we can just add new plot here. Okay. For this cosine function, the color is green, and I give the label as y equals cosine x. Okay. Okay. I think cosine x, sine x. Okay. What is happening here? Y1 is, it should be the function, but np.cos. Let us see the y1 first. Okay. Okay, maybe I would like to plot the trigonometric function in two plots instead of one plot. Okay. We can make two plots side by side using plt.subplot. Okay, this is our previous code, and we copy it to another cell. Okay, I would like to use plt. So I add this subplot. The first subplot is this one. I will tell you how to make these subplots, and the second one is subplot 1, 2, 2. Okay. Let me explain to you this. What does this tell about? Okay. In this, the first plot is associated with this sine function, and this one is the ordering of the subplots. So here it means that there are only one row, okay, only one row, and there are two columns, okay, two columns. This one is the first column, and this one is the second column. And on the first column, we plot the first sine function, and we use 1 because it's the first plot. And here it's 2 because we are going to plot another function here. So plt.plot c y1 as our cosine function. Okay. C and y1 cosine function, cosine y1 equals, oh sorry, this is wrong. Okay, so previously I write it this def cosine x, but I don't return it as y. I return it as x, so it's wrong. So return as y, and you repeat the cell, and it will plot the correct trigonometric function. This is our cosine function. Okay, and in this second plot, I would like to give a title of cosine function. Cosine function. Okay, and size equals 18 and path equals 20. Okay, we can make a distance between two plots here. We can use plt.tight layout 1.2 is the distance between two plots. Okay. Farther away, for example, 0.6 plt.tight layout. Okay. And then we also add the label. Label equals cos x. Okay. And don't forget to add the plt.legend. Otherwise, you won't get the label here. Okay. plt.grid, you have to repeat it for each subplot. Okay. These are our first plot. And the next important thing is using NumPy, we can make random numbers. So for example, I would like to generate a random an array consisting of random numbers, okay, from 0 to 1 into 50 numbers. So there are 50 numbers in an array from 0 to 1, and this function will generate a random numbers from 0 to 1 into 50 numbers here. Okay. Two more. Okay, so sorry, this is only this 50. So this will generate all the numbers from 0 to 50. Okay. So sorry, this is maybe G equals this, and print our array. This is our random numbers. And on this random numbers, I would like to add this to our previous array. Okay. I would like to add G to, because we already have print the y. This is our cosine. This is our sine function. Okay. Okay. So because I would like to add an array to an array, we have to make that array into a similar dimension. Because previously I did making the array of 100 numbers. Again, this one I would like to generate the random numbers into 100 numbers. Okay, so this is our random array, and this is our previous array. On this array, I'd like to add, for example, P equals y plus G, and we print this one. Okay. So why I'm making this? This is I would like to produce a noisy function. So before we have already make a plot of C and Y, this is our sine function. And on this sine function, I would like to add some noise, okay? So this one, the another array. Okay, so I will show you this one. Okay, so y plus g, or I just declare it as noise to make it easier to understand. Okay, so this is our noise, and I'd like to add some noise to our graph here. Okay, so this is our first plot. This is the sine function, and the second plot is actually our sine function, but we have generated random numbers from 0 to 1, and we add it to our previous y, so it will seen as a noise. Okay, noise is quite important in geophysics. We are working with signals and anomalies. That is very noisy. And later on, maybe I will share you how to filter this noise in Python. But first of all, we go straight to another library, which is Pandas. Okay, so you can actually you can add your own text here. This is Pandas. Okay, so right now you would like to get to know about Pandas. Pandas is a library for data processing, and the way we are making a data, we make a spreadsheet using a Panda. So, for example, we have already had the X array. So print X. This is our first. Okay, or maybe I would like to make a new data. For example, I would like to make an array of names. For example, John and Peter, and for example, Ashley. This is a list of names, Bob and Ronald. For these names, okay, they have ages. For example, John is 13, 14, 20, 25, and 78. Okay, and Z is their nationality. John is from Germany, and Peter is from France. Ashley is from Egypt. Okay, Bob is from USA, and Ronald is from Norway. Okay, this is our data, and on this data, I would like to create this into a spreadsheet, into a table. The way we are using this, we are doing this is by we type as data equals. Here we have already imported a library that's called Pandas and abbreviated as PD. Okay, so the way we have to do this, we have to add pd data frame, okay, bracket and curly brackets. So don't forget with this kind of typing. Okay, in this I would like to add a new column. The first one is name. Okay, for this name column, it will take an input of X. Okay, because X is a list of names, so it's specified as X, and ages is Y. Okay, this one is their ages, and the nationality is Z. Okay, and if we print this data, it will print us the table. Okay, this is our table, and this is the first column: name, ages, and nationality. If we want to preview the data, for example, the first two rows, we can use this head to. Or if we want to print the last two rows, we use tail. Okay. Okay. This is our last two rows. So I would like to show it all the data here. Okay. And if we want to add some new data, we just use like this data brackets. Maybe I would like to define their occupation or job. Okay, and so John is a carpenter, and Peter is a math logger. Okay, Ashley is a petrophysicist. Bob is a businessman, and Ronald is a dentist. Okay, and if we print our new data, it will print another column here. This is their occupation. And if you want to add some more data, you can use another data, for example, DOB or date of birth, 1999, 91, 96, 1978, 2002, maybe, and it will print another column here. Okay. The next important thing is how to assess the information from each column. So for example, I'd like to print all the data in the nationality column. Okay, we print this one. Okay, so this one, data nationality, it's all the information in the nationality. And for sometimes we need to convert this information back into an array. Okay, so we can use this dot values, and it will print us all this information back into our original array. So this is our original array. Okay, and okay, so this is back to our original array. Okay. So for instance, this is quite important when we do in data analytics or data science. We have to convert one table into array and convert back array into a table. This is really frequent in processing the data and analyzing the data and wrangling the data. Okay, and we can do, for example, some operations with our table. Maybe I would like to think of another idea. Okay, so for DOB, okay, so here I would like uh, to calculate the difference between the consecutive names. For example, the difference in ages. Sorry, the difference in date of birth from Peter and John, Ashley and Peter, Bob and Ashley, and Ronald and Bob. Okay. So remember, we have to convert this table back into an array. So we use this date of birth equals data, and this one is DOB, and we place it dot values to make it as an array. Okay. So it will print the array of this date of birth. And I would like to take a difference between consecutive years. We use difference equals NP. We are again using NumPy. And from this NumPy, we are using diff function. So DOB. And if we print the difference, okay, so it will print us the difference in years. This one is 1, and okay, so this is logical, minus 24, 11, and 24. Okay, for this, maybe another interesting thing is on how to, okay, okay. So we can also do another thing with this table. Okay, for instance, we are making a new table, okay? A new table that is called as a company or, sorry, company, and panda or, so I still think of another idea on how to play with this data frame. Okay, ages, nationality, and occupation. Okay, name, or maybe we can add some more information here. Data, maybe company where they are working right now, and Chevron or McDonald's, and KFC, or Shell and Baker Hughes. Okay, and we print the data, it will print the new data. Okay. Okay. So the next thing is I would like to access the data from this table. So for example, I would like to get all the data from Peter. Okay. The age of Peter, the nationality of Peter, his occupation, his date of birth, and his company. Okay, so how to do this? We are using what is called as regular expression. So the next task is to print all of the data of Peter. Okay. So how we are doing this? We can use we first we make a mask. Okay, mask equals data. Okay, because data is our table. Data, the name of the column is name. Okay, and this one is Peter. Okay, so let me explain this line of code. Here, I would like to get all of the information from Peter: his age, his nationality, his occupation, and from this data, I search the name here that is exactly Peter here. Okay, so data, this is our column. Okay, and it equals to Peter. And if we print our mask here, we can see which one is the true value here. So the 0, okay, the first row is John, so it returns as false. This is called as a Boolean array because it returns as true and false. And the first row is Peter, so it returns as true, and the other result as false. Okay, how we get or how we access all of the informations from Peter? We use this mask to this data. So if we apply data brackets mask, we get all of the information from Peter. Okay, this one is our all of the information from Peter. Okay, or for example, I would like to get to get a name of person who works for Chevron. Okay, because we are searching in this company column. So print all of the data. So print who is working for Chevron. So in our mask, we use the data company. This is our column, and this is our this is the name of the company we'd like to search. And if we print this, okay, so it will print exactly the person who works for company Chevron. Okay, and I would like to show you also. Okay, so another important thing is I would like, from this data, I would like to get who was born later than 1960, sorry, 1990. Okay, so I would like to print all of the names was born later than 1990. Okay, so this will be Peter and Ronald. Okay, so we are using the same concept here. Okay, but right here, so print the names was born after 1990. Okay, so because we would like to search for this in this date of birth, again, we specify our column, the date of birth, and for this date of birth, we print all of the data larger than 1990. Okay, I hope you understand this. What I write here, and if we print the data, okay, so it will print all of the names that was born after 1990. So that's true. This Peter and Ronald, or maybe before 1998, 1980. Okay, this is Ashley and Bob. Okay, this is actually the basics of data analysis. It's not a special thing about data analysis or data science. It's just about how we get lots of information and insights from the data, because it is not every time about machine learning or other cool names. For example, artificial intelligence. Data science is just how we get an insight from the data. Here, what I did is I would like to search who was born after 1990. So this is actually an important thing to know from our data. Okay, so from this data we do lots of analysis. We already did a calculation within this date of birth. We calculate the difference between ages of the names of this person. Okay, so when we are later working on Velox or other data, we will handle all of this data into this form of data. This is form of spreadsheet. Okay, so in Velox we know there are lots of logs. For example, about density or porosity, and we print all of this all of the data. We analyze the data using this data frame. Okay, so every time we are working with files, for example, the CSV file or Excel file, first we convert into the data frame, and then we can do lots of operations within that data frame. Okay. Also, another cool library in Python is called the Scipy. It's not cool anyway. It's a pretty complicated library for doing scientific computation, but it's quite useful because in petroleum engineering we are dealing with lots of problems that requires curve fitting or interpolation, extrapolation, or root finding, and all of these things need Scipy as the library to do so. For example, now I would like to do a curve fit. Okay, curve fitting. Okay, curve fitting, as you know, we have a data and we would like to fit this data with a certain function or a certain curve. Okay, this is really common in reservoir engineering. For example, anyone is working as a reservoir engineer, working with material balance data. You want to search for the OIP or original oil in place. You have to fit the data with a line that represents the OIP. So this is the basic of doing the curve fitting using the Scipy. So first of all, I would like to make a new array. For example, X is an array from 0 to from 0 to, sorry, from 50 from 0.1 to maybe this one's okay. and into 100 numbers. And I would like to convert this array using a certain function that is called an exponential function. So here I create another function that is called the exponential, or maybe polynomial. Okay, polynomial, and x. Okay, x, and it will return as 0.5 times x to the power of 2. So this is the power of 2, x to the power of 2, and 0.7 times x plus 10. Okay, so this is our function, and if we print the result of this function, polynomial x, okay, and then I would like to plot this x and y. Don't forget to use this plt.show to show our plot. Okay, so this is our data. Okay, maybe I would like we can instead of using plot, we can use scatter. Instead of line plot, we can use a scatter plot. Okay, so this is our data right here. And previously we have discussed how to make a noise here. And on this data, because it's quite perfect, I would like to add some noise here. The noise I would like to generate from is a random noise, because there are 100 numbers here. Okay, we are using the same amount of numbers here. So for this, this is our data, and the second is our data after I apply the noise. Okay. So this one, maybe I can amplify this noise to make it more pronounced. Still not showing. Okay, so this is our noise here. Maybe I would like to color it as red to make it clear. This is our data after we apply some noise. Okay. Okay. So, okay. For example, 0 times this one. Okay. So this is our data here. In nature, we are encountering lots of data that has lots of noises here. All data in petroleum engineering and all basically all things industrial engineering, we don't get a kind of perfect data. It is always concentrated with noises. Okay, so on this data, I would like to fit this data into with a curve, because we have already known this is our function here. Okay, so assume we just so okay, so we assume that we don't know this function. Okay, we don't know this function. Okay, we are completely blank with the function. We don't know the function. We don't know the coefficient. These are our coefficients. This 0.5, 0.7, and 10. We don't know the coefficients. We just know the data. This is our data. And on this data, we'd like to fit a curve that most perfectly fit with this data. Okay. So to do a curve fit in Scipy, we use from Scipy, I think so, Scipy optimize import curve fit. Okay. So in Scipy, there are lots of libraries. One of the libraries is called Optimize. Optimize is a library to do an optimization problem. If you are knowing about machine learning, it's all about how we optimize the parameters optimize the learning of the data. So in Scipy, we have optimize here, optimize library. And from this optimize library, we import a function that is called the curve fit. Okay. So in this, I would like to show you that if you want to get some information about what the function that you will use, you can use this help and the name of your function. And this is basically all of the documentation of the function here. All of the information, what is the input required for this function, and what is the additional inputs here. Okay. So with this data, I would like to do a curve fit. Okay. Actually, we have already know the function, but we don't know the coefficients. As I said earlier, I would like to use this. Our function is like this. Sorry, function is like this. Y equals I can just copy this function. Okay, y equals. So we don't know about the coefficients, so we call it as a coefficient. We don't know that it is 0.7, and this one is c. Okay. So this is our function here. Okay, so maybe okay, this one, ax square bx. Okay, this is our function. And with this curve fit, I would like to search what is the best A, B, and C. And I hope that this A, B, and C is equal or at least near to this number, 0.5, 0.7, and 10. Okay. So the first thing, we define our function, function, or maybe polynomial fit, or anything you want, function fit. Okay, this is our name of our function with x, but because we don't know the a, b, and c, okay, we just type all of these coefficients. Okay, so it will return us, sorry, y equals a times x squared plus b times x plus c, and it returns the y output. Okay, this is our function that we don't know yet about what is a, b, and c. Okay, but we have already had the data. This is our data, okay, x and y. This is our data. Okay, this is our data x. Sorry. Okay, so maybe it's better to use another variable, x data, y data, y data equals y plus noise, and this one is y data. Okay, so we have x and y data as our data. So x and y data are our data that hasn't been fitted. Okay, we can have all of this ABC by using the curve fit function. Okay, so we can use this curve fit function. We pass the name of our function. Okay, the name of our function is function underscore fit, maybe function or polynomial fit, polynomial 2, maybe, because we don't know the a, x, and b. Okay, it can be anything. You would like to name it as polynomial or exponential or anything, any function that you want to fit this curve. Okay, so because our function is called polynomial 2, so we first make an input of polynomial. 2 is our function. And the next two inputs are our data. So we have X as our data and Y data. So this is our data, okay? If we run this, we will see some outputs here. But you just have to take a look at this alone. This is our output, okay? So what is this? This is A and this is B and this is C, okay? So with this curve fit, we have already know about A, B, and C. Because I said earlier that hopefully we come up with a result that is close to this number, okay? So A is actually 0.5. So this one is close to 1, okay, and this one is close to, actually it's not very close to this one, but it's okay because this is called curve fit. And if we plot this fitted function, y fit equals polynomial, okay. So okay, polynomial 2 with x is our data. So we just copied this. We just copied this A equals is 1.16, and C equals C equals 52.62. Okay, so this is our y fit. Y fit is the fitted function, and if we plot the data first, this is our data. We use scatter. Okay, this is our data, and after we use the curve fitting, we produce with this plt.plot x and y fit. Okay, so this line is exactly our fitted curve here. Okay, maybe I'd like to color it as red. This is quite important in lots of things in petroleum engineering because you have to fit the data with a certain function, okay? And this is basically the Scipy. Maybe there are also, other than curve fitting, we have also, we can use another, for example, root finding or, okay, root finding. There are lots of applications in Scipy, root finding or interpolation or extrapolation, okay? There are lots of stuffs we can do with Scipy. And this is a basic thing in programming in oil and gas. Maybe the last library that I would like to show you that is called Plotly. So Plotly is a library that is quite similar to Matplotlib, but it's more interactive. So because we haven't imported Plotly, we import Plotly. So plotly.express as px. So you can write as this, import plotly.express as px. Okay. Okay. And with Plotly, I would like to plot this this function, but right now in Plotly. Okay. So the first thing we can use px figure equals px dot scatter x equals x and y equals y data. And fig.show. So don't forget you have to use this fig.show to show the plots in Plotly. Okay. So it okay. So this is our visualization in another flavor. So here you just have a static plot, But with Plotly, we can interact more with this data. Okay, it seems cool, right? So we okay. Maybe I would like to colorize all of this scatter with Y data to make it more colorful. Oops, maybe color. Okay, color. Okay, so color is this represents the color represents the Y value. Okay, and in this plot, I will plot the curve, the fitted curve here. So we have to um, fig equals maybe fig equals px dot plot px dot line. I still try for this if it is successful. So hopefully it can run this line. X and y equals y fit. Okay. Mhm. Okay, so maybe I have to. Okay. Um, um, one disadvantage of using Plotly is that we cannot plot more than one graph in just one plot. Okay, so instead of this, we have another Plotly style that is called as graph objects. Okay, as go. We can add our own plots. Okay, so for example, fig is go dot figure. Okay, so this is go dot figure, go dot figure. Okay, and fig dot add trace go scatter. I think this one is the right input. Y equals y data. Okay, there's something wrong with the code. Go scatter. Okay, go scatter. Module object is not callable. Go dot scatter. I think go dot scatter 3D. Okay, go dot scatter. Go dot. Yeah, basically, I would like to show this curve fit line into this line plot, but um, actually there are lots of methods to do visualizations in Python. There are lots of other libraries. For example, Seabourn. This visualization tool is for data analysis, and Plotly is for interactive plotting. And we can do lots of things with this Plotly library. You just have curiosity, and an urge to learn something new from the internet, because all of the information you can find all at once in the internet, and you can read the documentation to do lots of things, lots of other things in Python. Histogram, because it's quite important before we continue our session next week on data. We are using, so we have already had the data. This is our data, and plt.histogram of x. Okay, okay, so here this is our data, and if we plot the histogram with Matplotlib. Okay, so y data, I think y data. So I would like to make a histogram of a data. Okay, so this is a y data thing. Okay, so this is our histogram. So another thing we use in data analysis is we use a histogram to visualize our data. So I think that's all for today. We have covered lots of things today from NumPy, Matplotlib, and Pandas to do basic thing in Python. We know how to make an array and then make a function and how to plot a function into one plots or into two plots here. Okay, and we give the attribute, the grids, the title, the labels, and the color of the graph. And then we have already done on how to generate random numbers, because random numbers is a magic thing when we are analyzing the data. If we don't have any data from the field, we can even make our own data. That is called asynthetic data. There is nothing wrong in making our own synthetic data, because if we don't have any data, we can make it our own. And this is the basic thing of generating random numbers using numpy.random. And then we also covered on how to add two arrays. So this is the first array, and this is the second array. The noise, the second array is our data. We add it as noise and we plot it here. This is our smooth and perfect line, and this is our crooked and noisy lines. And we use pandas to make a data frame here that consists of several information. Here we add some new information to our data, and we do some we add new columns, and and the thing that I stressed before is how to wrangle or how to process with the data, or how to get some insights from the data. Here, for example, I retrieve all of the information. Who is working for Chevron? That is John is working for Chevron, and who was born after 1990. So it will print all of the information about the date of birth of the names that was born after 1990. Okay, so this is the basic of pandas. Okay, so actually next week we will I think we will deal with a real data, with a field data set that is in format of Excel spreadsheet, and we will use a pandas once again to load this data into our Python. Okay, and then after that we have already learned how to do curve fitting in Scipy, because curve fitting is a basic and most fundamental thing when we are doing in reservoir engineering called a material balance analysis. We are fitting with a curve to find the hydrocarbon in place. Okay, or in geophysics maybe you can fit a data, you can fit with a field data, a magnetic or gravity data with a certain function for exploration. Okay, so we generate our own data here with the Y with noises, and from this we have made a new function. The first one, we assume that we don't know the function, the A, B, and C coefficients, and the curve fit will search the best A, B, and C to fit with this data. We use the curve fit to fit the data polynomials. The curve fit polynomials. This is our function, and this is our data. And on this data, this is our result here. Actually, you don't have to be worried about what does this mean. This is one of the stuff discussed in numerical methods. It's called a covariance, but you don't have to know it for now. This is our result. This is the A, B, and C coefficients that will fit this polynomial to this data. So after we have already done the curve fitting, we plot the result with this new fitted curve. And also, there are lots of methods in Scipy, for example, the root finding, lots of other things. Maybe if we have another time in the future, I will share you how to do this, because it's quite complicated and we have to go from theory and then implementation. And then the last thing we have already discussed on how to make our plot interactive. So this is quite interesting because in data analysis we have to visualize our data as interesting as it's possible to show with our stakeholders or to show with other people on how to communicate the data and how to get information from the data. For example, here we can interact with data, or okay, so I forgot to show you here. We can zoom in this data, okay, or maybe we can do this, okay. So it's quite fun to play with Plotly. So okay, so this is okay. Maybe so here pen, okay, box select this, okay. So don't worry about this. We can also reset access, okay. So we can download it as PNG or other image format. And then the last thing is we plot a histogram to our data. So actually that's all for today. If you have any question for this session, you would like to ask anything about Python, or you would like to repeat that maybe I wasn't clear about this part, you can freely ask to me. And okay, so that's our final tutorial for today. So thank you for your attention, everyone.
We'll begin by addressing some questions. Now, regarding the regression factor square from the curve fitting, can we get this R factor using Python?
Sorry, the question is how to get
the regression factor R square from curve fitting.
Oh, that's a really good question. So actually, yeah, we can get the metric from this Scipy library. So maybe you are referring to R squared or RMSE or root mean square error. Yeah, you can get those information from this from using this Scipy. Only maybe I don't quite remember on how to do so. You can visit the documentation of Scipy curvefit, and you can measure the R squared. But anyway, we can actually make a function that calculates the R squared. So let me show you. Here we already have the data here after fitting and before fitting. So this is our data, print X and Y data. This is our data, and this is our fitted data, okay? So the R squared is actually the difference, the difference between this, the difference between the fitted data and the data, right? So actually we can make our own function here. So for example, a function that is called square R squared, okay? Actually, I don't quite remember about the formula, but at least I did it right here. So this is our data, and this is our fitted data, and R squared equals, because it is not a square root, so it is not a square root. So this one, I think NP, sorry, this squared and y fit minus y data, okay, and then over this this. So first of all, we have this data, right? This y data and y fit. We subtract this y fit with this y data, and then we take the power of 2 from the difference, and then we sum all of them, all of the squared values. I hope it's a quite it is the right formula for R squared. So if I print the r squared, print r squared, okay, r squared y data and y fit, it will print us the error of this. Oh, so this is not right. Maybe np dot this is maybe dot square root. I don't quite remember the formula. Maybe okay, r squared. It must be 0 point something. Okay, so actually, if we know a function, we can make our own function and then we can apply it to our data, even if the library in Python doesn't have a capability to do so. We can make a new function and then we can we can do that with our own data actually. So this is quite important. R squared and RMSE. In the next week, we talk about data analysis and fitting a curve, and we need this metric to know how good is our curve fit and our estimation of our parameters. Okay, so thank you for your question.
Question is that is it possible to merge data sets from different sources?
To match the data set from the printed, sorry, to
To
combine
merge,
from the printed sources. Yeah,
combine?
actually,
No, from different sources.
from the printed sources.
Yes, no, yes.
Okay,
Yohanes from different sources.
from
Different.
different sources.
Yes.
Oh, okay. So yeah, it is possible because there are lots of formats. For example, a binary file, TXT or CSV, or even image. Image is a kind of data in JPEG or PNG, and we can import all of this data in Python. Only we have to care about which library to use. If we want to load a binary file, for example, a text file in a notepad, we will use NumPy. So maybe you want to search it for yourself, np.loadText. This is a function for loading a TXT file. Okay, and if you want to load a CSV file, which we will cover next week, we use this read.csv. This is Pandas, so this is for loading CSV file. Okay, and for specific in oil and gas, for example, well off, we are using last data. These libraries that we are talking today, they cannot load this kind of data. There is a specific libraries you can search in the internet. There are lots of libraries that people are developing each day. There are lots of maybe thousands of libraries are developed by many people. And one of the libraries to import, for example, the last file is called the Lysio library. You can search it for yourself, and maybe in seismic data, because it's in segway file, we use some segway-o library to import this data. So basically, any data can be imported in Python. Only you have to find first. If you don't find maybe for your certain file you don't have any you don't find any specific library in Python, you can make it yourself. Because Python is an open source, you can even create your own program. You can create your own library to do your own purpose. So basically, in general, any file can be imported in Python. A PNG file, image file, or TXT can be imported and it can be extracted as data. So
Okay,
any other
thank
question?
you. Now the last question for today. Is there any specific book you recommend to learn Python or the application of Python in petroleum engineering?
Oh yeah, there are lots of there are lots of books I know, and I would like to say that to learn Python there are lots of ways. I personally like when I started learning Python several years ago. I started from a course and then I do a mini self project. I take a textbook and then I try to translate all of the problems. If you have already heard about a book from Brian Toller, it's a SP textbook in Reservoir Engineering. Last year, I translated all the problems into a code. So it is I think it's a painstaking effort, but it's quite effective to do Python learning. But I have some recommendations for books to learn Python. For example, you can search names, for example, Jake Vanderplas or Jake VDP, and the title of the book is um, Python Handbook for Data Science. Python Handbook for Data Science. It's a very good book for learning Python. And another good book that I recommend, you can search here already books for Python. There are lots of good books published by this publisher, so you can search here. So I'd like to. Python is a good book to learn Python, and Vanderplas book. You can search it in the internet. It's quite free. Okay, you can access all of the codes. You can practice it every time, and you can access it for free. There are lots of resources, lots of cool resources. You can learn Python from books, but also I recommend you to learn from videos from YouTube, because if you want to dig deeper into lots of stuffs in Python, you would like to do a self project, you can see lots of videos in YouTube. They are free. You don't have to purchase like in online course. Except that you want to have a certificate in learning Python, but learning from books and learning from videos and do a self project with a real field data set is the most useful way to learn Python. So so based on my personal experience, I do a self project, and within maybe 2 or 3 months, I can be confident in running your own codes. And this session, I hope that today I already touched about the basic Python programming, and next week we will dive deeper to applications. But if you want some recommendations of Python programming in oil and gas or geoscience, I think there haven't been any books for that. Maybe I know some books for machine learning with Python by Jos Beliadi. That's a good book in machine learning with Python for oil and gas, but it's quite a few books for that. So I think the good thing is that Python for oil and gas is a scarce or rare materials, but you can learn the Python basics first, and then you apply to your own fields or your own study. So that's my recommendation. I hope it works for you. Yeah.
All enjoyed this session today. To highlight, this session has been recorded. It will be uploaded soon on PyOpetra's YouTube channel. And as a reminder, please check the Google Classroom for quizzes. Quizzes are uploaded regularly, so try your best to do them before the assigned deadline. You should at least get an average of 70% on the quizzes and 70% on the final exam in order to get your certificate, along with 10 Zoom webinars which you should attend live, minimum of 10. Now that's all for today. Have a nice day and see you in future webinar. Thank you.
Thank you everyone for joining, and thank you Mariam for moderating, and thank you Professor Algarhi for this interesting session. And I hope to see you all next week. Thank you.